of any of them that aren't in our own solar system, Proxima b.
Went out to 1 million miles from Earth in the opposite direction of the Sun.
If you've ever wondered why humans exist only on Earth, you're not alone. We've been looking for an answer for millennia. Another intriguing question is whether or not we are the only beings in the cosmos. Are there aliens wondering if they too are alone in the universe? Are they attempting to reach out to us? Are they even looking at us? We've spent billions of dollars on these issues, but we still don't have definitive answers. So stick around until the end, because things are going to get really interesting. Is there an alien civilization right around the corner? Maybe it is possible. Around late 2020, scientists noticed a signal coming from the direction of Proxima Centauri, our nearest neighbour star. Named BLC-1 by Project Breakthrough Listen, the signal is still being analysed to ensure it isn't merely an echo of our own civilization, as they usually are. But why not just look at planets around Proxima Centauri and see if there is a civilization there? Enter the James Webb Space Telescope. One of the James Webb Space Telescope's major goals is to hunt for habitable exoplanets, where we might one day find evidence of life beyond our own planet. Scientists are seeking for lights that could be the final piece of evidence that an exoplanet known as Proxima b is inhabited by aliens, utilizing the new and powerful JWST. However, habitability is a delicate issue, and finding another Earth-like planet may be more difficult than you think. Mars is being viewed as the next likely planet to accommodate humans, with Elon Musk's SpaceX leading the fight to establish a permanent human colony on the planet. Microbial life may already exist on Mars, maybe beneath the planet's ice caps or in subsurface lakes discovered by satellites like the European Space Agency's Mars Express. These kinds of sites could protect life from the harsh conditions on the planet's surface. Because the type of life we believe could exist on Mars presently is microbial, an orbiting spacecraft's cameras would not detect it. Instead, we may identify it indirectly using biosignatures, which are chemical fingerprints linked to life. Mars is quite close to Earth, making it viable to transport humans there, albeit a tough journey. However, much further out in space, there is a class of planets known as exoplanets, which will be the focus of today's video. The planets in our solar system all circle around the Sun. Planets that orbit other stars are known as exoplanets. Exoplanets are extremely difficult to directly observe using telescopes. They are hidden by the bright light of the stars they orbit. As a result, astronomers use different ways to detect and study these distant planets. They search for exoplanets by studying the effects these planets have on the stars they circle. It's likely that you're familiar with the exoplanet known as a hot Jupiter, which is one of the most prevalent varieties. They have the features of gas giants, but since they orbit so close to their stars, their surfaces and atmospheres are extremely hot. They also travel very quickly around their star, sometimes in less than a day. Another fascinating sort of exoplanet is lava worlds, which are Earth-sized exoplanets with extremely high temperatures. Kepler 70ab is one such example, orbiting its star at only 1% the distance between Earth and the Sun. Kepler 78b's surface temperature is almost definitely higher than 2000 degrees Celsius. One of the primary goals of the James Webb Space Telescope is to identify habitable exoplanets where we might one day find evidence of intelligent extraterrestrial life. There is a spectacular star system located roughly 40 light-years away. The TRAPPIST-1 system sprang to prominence 5 years ago when NASA and its collaborators announced the discovery of several Earth-sized planets in the habitable zone of a single star. Since then, scientists have been working feverishly to learn everything they can about these nearby worlds that may be similar to Earth. When NASA scientists launched the cutting-edge James Webb Space Telescope from the Guyana Space Center on December 25, 2021, they had no idea what they were getting themselves into. Astronomers expected to find indications of life in the atmospheres of distant planets and galaxies, but they had no idea that the first images from the JWST would change the way we perceive space. The closest known exoplanet to Earth that potentially supports life is only 4.2 light-years away. This super-Earth, known as Proxima Centauri b, is somewhat larger than Earth and resides in our neighbouring planetary system. It circles around Proxima Centauri, a red dwarf star in the triple star system Alpha Centauri. Proxima b's smallest probable mass is only 17% more massive than our planet. This new discovery implies that Proxima b is more comparable to Earth, at least in size, than prior measurements revealed. So what's the story behind this Earth-sized planet? This intriguing alien world revolves around Proxima Centauri, our Sun's nearest neighbour. Because the planet orbits in the habitable zone of its star, liquid water and potentially life could exist there. Scientists believe Proxima b, because of its Earth-like mass, could not only have liquid water, but also be a rocky terrestrial planet like Earth. Proxima b, on the other hand, circles a star that, while close to our solar system, is much brighter and less massive than our Sun. The exoplanet is thought to be tidally locked and rotating in sync with its star, which means one side is always facing the star and the other is always facing away, a light side and a dark side. How will the JWST show the presence of life? It's unclear if Proxima b has an atmosphere. Every 11 Earth days, the planet completes one orbit around its star. As a result, some astronomers believe that Proxima Centauri's radiation may have stripped away Proxima b's air, rendering the alien planet's surface incapable of maintaining liquid water. Scientists will be able to better understand what it's like on Proxima b and uncover its secrets now that we have the JWST. If Proxima b does have an atmosphere, the necessary components for the production of the biochemical cycles that compose life, including as water, carbon dioxide and rock, might all be present and interacting on the planet's surface. While radio signals have been detected near Proxima b, radio astronomers believe that while radio signals have been detected near Proxima b, they were most likely noise from other sources. As a result, any civilization that lives on the exoplanet may need to deploy strong mirrors or utilize incredibly brilliant LED-style lights to illuminate their cities, because the radiation-free side of the exoplanet is always dark. The brightness of our planet's night side is the clearest sign that someone lives on Earth from space. Light from our cities is mirrored in the cosmos. Our present generation of telescopes are insufficiently powerful to detect lights on other worlds. However, numerous researchers have already tested the capabilities of the next generation James Webb Space Telescope. What was discovered? If advanced enough or bright enough, we would be able to see if another civilization has the lights on at Proxima Centauri. There are several methods for detecting alien technology on another world. For example, the transit of a massive satellite constellation in our direction may allow us to watch the light of a distant planet flicker. Nuclear confrontation might cause atmospheric pollution. While these technical indicators may be caused by natural occurrences, like as orbital debris or a comet collision, artificial illumination differs from natural starlight. Stanford University's ELISA TABOR and Harvard University's Abraham Loeb put the JWST through its paces. Tabor and Loeb computed artificial illumination as a percentage of solar illumination reflected from the day side of the planet. On this scale, 0% indicates that the night side of the planet is completely dark with no artificial illumination. 100% indicates that the planet's night side is just as bright as its day side. The light used by the possible civilization on Proxima b is expected to be similar to that used by LEDs on Earth, which have a distinct artificial spectrum. What were the results? If the artificial night side illumination of Proxima b approaches 5% of the natural day side illumination, JWST might identify artificial light with 85% accuracy. When artificial illumination reaches 9%, JWST's detection confidence rises to 95%. Does 5% illumination seem like much? After all, we're talking about starlight. Despite the fact that Proxima Centauri is 20,000 times fainter than our Sun, it's a lot of light. Artificial illumination on Earth, in comparison, accounts for only 0.001% of the reflected stellar illumination. In other words, if Proxima b has a civilization as advanced as ours, JWST would miss it. Those lights must be 1,000 times brighter. That is a reasonable scenario. Proxima b orbits its host star so closely that it is possible that it is tidally locked, with one side of the planet always facing the star and the other in perpetual darkness. A civilization on a tidally locked planet may need to prioritize illumination infrastructure, and as TABOR and Loeb propose, may use extremely strong circling mirrors to reflect sunlight onto the planet's night side, which our telescopes can view. Future telescopes, such as LUVOIR, Large UV Optical Infrared Surveyor, according to TABOR and Loeb, may be even better than JWST at detecting the glow of a distant civilization. Both LUVOIR and HabEx are scheduled to launch in 2035, with missions to catalogue and picture exoplanets. If an alien culture exists, it may have already acquired this level of urbanization, assuming that technological civilizations live a long time. The truth is, we don't know how long technological civilizations live. Finding someone else glowing in the darkness offers us hope that we too can keep the lights on. If there is intelligent extraterrestrial life on Proxima Centauri b, they may be staring back at us with their own telescopes, wondering if they are alone in the universe just as we do. What are your thoughts about it? Do you think Proxima b is home to intelligent life? Tell us about it in the comments section.